Okay, so we're going to look at 3D shapes, and then we're going to start with the surface area of 3D shapes. So 3D shapes, as I told you earlier in the previous lesson, that 3D shapes are made of 3D shapes, right? And they're folded together to make that 3D shape. So what I can do is I can actually take my 3D shape and I can unfold it and I can make what we call a net. So this is called, when I unfold my 3D shape, okay, when I cut it and make it into 2D shapes, we call this a net.
What?
It's called a net. Net. N-E-T. That's what it's called. Net. Okay? So a net is a 2D pattern that can be folded to form a 3D shape. Okay? So think of a pizza box. When they bring you the pizza box, if you work in a pizza restaurant, they bring you the pizza box as open boxes, and then you have to fold them to make that 3D box. Okay? So it's made up of one piece of cardboard that is a 2D cardboard, and then it gets folded to make the rectangular prism. So if I'm looking at the surface area of that prism, right, if I want to find what's my surface area of this prism, whatever the prism is, all what I have to do is I have to take the prism and I have to unfold it and find the area of each of the 2D shapes that it makes it. Does that make sense to you? Okay, so you take the 3D shape, you unfold, and then you find the area of each of the shapes, and you add them all together, like we did in the previous lesson with the composite figure. Okay? So, just so you guys know, I can't be very bad at drawing, okay? So if this looks something like, it looks like an alien, it's just because I can't draw. Okay, so if the question is asking you to draw the net of the following prism, okay? So what do you see here? A rectangle. Okay. That's right. So how many rectangles do you see? 5. So there's going to be one here, right? There's going to be one here, one at the bottom, right? And then 2 on the other side that matches these, right? So that means I have 5 rectangles. Does that make sense? Okay. Are they equal rectangles? Yes, because if this is 10, that means this is 10, right? So it's going to be 10 by 30. The other one's going to be 10 by 30. This is already given to me as 10 as well, so it's 10 by 30. And my bottom is 10 by 30. So it happened that this side, and this side, and this side, they are equal sides. Okay? If they're not equal sides, then my rectangles, they're not going to be the same size. But it happened that this is a regular, we call that pentagon. Okay? Why is this called a pentagon, this side, this shape here? It has 5 corners. Okay? So it's a pentagon. Technically, this shape, I don't split it. I leave it as a pentagon. Okay? So what I have is I have 5 rectangles, okay, and 2 pentagons on each side, right? So if I split, I don't have a pentagon here in this, but what I have, so this is how my net is going to look like. So I'm going to try my best, okay? So you're going to have the 5 rectangles, I mean. Okay, so that's 1. They should be equal to each other. If they don't look equal, I apologize. 2, 3, 3, 4, 5. And then what I can do is in the middle, because it doesn't matter where you actually draw it, if you're going to draw it at the end or in the middle. I'm going to draw it in the middle. I'm going to draw a pentagon. Okay. And these pentagons should be equal to each other. Okay.
Are you
So
going to penalize us if we don't know how to draw?
are you gonna penalize me if I don't know how to draw?
Yeah,
Trust me, if I didn't have this feature here, I wouldn't be able to draw this. Okay, but as long as you can show me that what you see, right? It doesn't have to be. I mean, it's better if it's a bit to scale, and then if it makes sense, if you look at them, at least you think that they're equal to each other, right? But if I look at this one, this is going to be 10, 10, 10, 10, 10, right? And then that means this here is 30, right? So if I say that this is 30, that means these are all 30, okay? And I can also include a measurement of 10 here, and that should be enough, okay? I don't have to write 10 all over these ones, so what you can do to indicate that these are all equal to each other, okay? What you can do is you can put 2 lines, okay, because I've already used the 1 line, so you can put 2 lines to indicate that all of these have the same measurement as this one, okay? So this for me, I'm indicating that all of these have the same size, the same measurement as the 10, okay? Are we okay with that? Actually, it doesn't look too bad. It's just my pentagon is a little not right. Okay, so basically what I did is I took this and I analyzed how many sides does it have, what kind of shape does it have. I kind of split it. I know I can't visualize. I'm sorry, guys. I'm very bad at this, and I understand if you can't either. But that's why I bought these. So I can see it. Okay, but I don't have the pentagon. All right. So what kind of shape do I have here? Triangular prism. Okay, so you should know the names of your shapes. If you look at your formula sheet, there's few of the most common used shapes, and there's names for them, but you should be able to identify your shapes. Okay, so a triangular prism looks like this. I call it sometimes a tent because it does look like a tent, right? So if you are to split this open, if you look at this, how many triangles do you see? Let's start with that. How many triangles do you see? 2 triangles, so these are your sides. And how many rectangles do you see? We have 3 rectangles, right? So if you look at this shape, if I'm going to actually cut open this shape, it's going to look like this, okay? With obviously different measurements, right? So it's going to be a rectangle here, a rectangle in the middle, rectangle, and then I'm going to have the 2 triangles. Okay? So if I'm going to draw this, if you look here, you have one, you have the bottom, and then you have the other side, right? If you don't have the visual one, right? And then you can see the 2 triangles here. So I'm going to do this. Again, all 3 rectangles, they are equal to each other. I don't know why this is not. Ooh. What's going on here? Okay, something is going on with this. It just doesn't want to work. Okay, stop. I'm trying to make them equal to each other. Okay, and then I'm going to draw 2 triangles. okay, on each side. You probably need a ruler for this unit. Okay, and if I want to put my sides, so you see that the triangle, it's an equilateral triangle, okay? So that means they're 15.2, 15.2, 15.2, all three sides of a triangle, okay? So this is the same thing as this, the same as this, same as my other sides, okay? So all of these are equal to each other, and they're equal to 15.2. And then I have this is equal to this, is equal to this, is equal to that, and they're all equal to 96.5 centimeter. Okay, if you want to add one more thing to this, you can add the height because the height is given to you. So the height of the triangle is 13.2, and you can add that here, and then you can say that this is 13.2 centimeter. Okay, this is just including everything that the actual 3D shape includes.
Are we expected to draw this?
Yeah, if I ask you to draw the net shape, you should be able to draw a net shape for me. If you can't draw without a ruler, I can let you borrow a ruler. What? It's not me, it's the curriculum. I love blaming it on the curriculum. Okay. If you ever need help with the shapes, you can always come and borrow a shape and then return it, just so to visualize. Okay. Look, doesn't it look like this? Except it's longer? Yeah, there you go. I didn't have to do much work. All right. So, can I get you guys to think about these three and then try them? Okay. Try drawing nets for these. Just flip for a second. Yeah. And make sure that you label your dimensions. Okay. So I'm going to give you time to work on this. Feel free to come and grab any of these 3D shapes to visualize if you need to. Okay?